All right, good morning. I wanted to kind of show off a project that I'm consulting on for a custom home builder in the area. And this home's going to be in La Cresta. There's a second one I did as well, but it's not as intricate as this one, and I'll probably still do a video on it. But I wanted to at least get this one out because, wow, this was a pretty big project, and there was a lot involved in kind of putting it all together. And there's still some things that we'll be doing along the way. I am working on getting bids from some of the local contractors for the builder, and it's definitely a doozy. So what are we looking at here? Well, this is just your front of the page of your plan set. If you were going solar with me or another company, I wouldn't say another company, but I mean, you always end up with a set of plans when you're going solar or getting a battery. There's typically a set of plans. The thing is that not everybody gives you a copy of them. I'm pretty particular on making sure you get your copy, and I have a copy, so that way we can go over everything and make sure that that contractor isn't changing anything or overlooking anything in terms of the equipment and or the location of some of the stuff. So we can see over here the scope of work. All right, we have 40 modules, 7.2 kilowatt DC system. That's 17,200 watts. That's 16,000 watts AC. These are using Q cell modules, North American, Qtron. So these are made in America, 430 watts. I decided to go with the Fronius USA inverter. So these are great units. This is the Gen 24 6.0 and the 10.0. So we have two inverters, and we're going to talk about why there's two. We also have a generator. This particular site, the homeowner wanted to have a third means of backup. So we basically have the trifecta of a backup system, which is really nice to see. And then here's our energy storage system. We have two A gates and 5 Franklin A power batteries. So that makes for 75 kilowatt hours of storage on this site. Yeah, no joke. It's a big system, and it is a ground mount. You can see that right here, ground mount. So let's kind of get into some of the details. This is an existing home that's having an addition done to it, and they're basically rebuilding the whole house. So this would be what your typical first page is going to look like on a set of plans. And if you already have a system, or you want me to just help design your system and get you some plans, my engineering team is great at putting these together. You consult with me. I can curate these plans for you. And just visit me online. I have my contact information all on every page for you. And then it's obviously in the description below. So here's what we're looking like on this property, which has a lot going on. So we can see there's an existing driveway. We also have an existing residence. And then this is going to be a new residence going in. So as we zoom in, what we can see is there's a lot going on. We have a transfer switch, the main panel, the meter, a rapid shutdown device, another rapid shutdown device, and then general electrical stuff. And then we have the generator that's over here. We have the propane tank that's over here. So there's a lot going on. So yeah, the existing residence is going to be converted into an ADU, and then this is the new building that's being built. And you can see that we have this ground mount that's roughly 400 feet away from the array, from the point of connection. So it's quite the run. And you can see there's a lot of equipment going down here. We have an AC disconnect, another AC disconnect. We have two inverters and sub panels, and then we have batteries. So yeah, definitely some interesting stuff. And you can see it's 40 modules, really clean layout. We did 4x10 in landscape. So we can see the trenching details are in here, right? And then we're going to be, for Riverside County, we have to put a mesh netting around it. So yeah, we're doing a polyurethane mesh around the array to ensure that it's compliant with the code. And it's just there to prevent people from getting their hands in there. It doesn't have to be like a metal thing. It's actually better that it's a polyurethane, because then you don't have to worry about having it grounded or anything. And then we have to maintain a 10-foot brush-free area around it. So yeah, but that's what we're kind of looking at on the scope of this project. And you can see everything's kind of labeled over here, right? Generational panel, that was the electrical panel. So there we go. And now here's where the fun starts. Now I split the equipment into, and you can see there's a lot going on over here. So we have a lot going on at the main house because we're feeding 2 different sub panels. It's a doozy. Now, what we're primarily looking at is 2 configurations. We have a 6.0 inverter, which is getting 16 panels connected to it. And then we have a 10.0 inverter. So that's a 10 kilowatt and a 6 kilowatt inverter. And that is getting the other, so if we have 16, the other 24 panels connected to it. And what we did is I wanted it to be kind of split down the middle, so that way there's room for expansion. So both sides are designed for expansion capabilities if this homeowner wanted to add more batteries, whether they're Franklin or I went the Gen 24s because technically what they could do is do a DC coupled battery with the Gen 24s. The A-Power equipment, Franklin whole home battery equipment, doesn't care that the solar equipment has a battery connected to it. It's just looking at it as it being solar energy. So if there's solar energy at midnight, their equipment doesn't care. It just wants to know that there's power available to them. It does get a little tricky. We would have to have specialized consumption CTs installed and whatnot, but I did kind of design it to be like a hybrid commercial style project for a robust expansion. The benefit of what I'm discussing allows for the Franklin batteries to not have to cycle as much, and you up your efficiency round trip specifically on the solar equipment, because you not only can charge your batteries that are connected to the Fronius Gen 24 inverters by a DC to DC connection, but you also get to use that storage before you tap into your Franklin batteries, which is kind of a cool idea. So I designed it to be a little bit unique. On the other project, we went the Tesla solar inverter, but that one doesn't have as robust of a backup system. It really just is they're just complying with the Title 24 requirements of having solar on a home. So you can see we have a lot going on over here at the ground mount, and this is going to be pretty detail oriented. So at the end of the day, and I'm excited because you're going to be able to witness this construction as long as you subscribe to the channel. So I'll be working close with the builder on this and the installers as well. So we haven't sent this project out because I just got the plans back from engineering the other day, and there were some small things that they needed to adjust after reviewing it, but yeah, we're in a good position on this project for sure. So this is kind of what you can expect from the ground mount. You can see that the modules are landscape and then going across, and you can see the railing is going up and down, and we have 2-inch posts. These are stainless steel posts going into the ground, and then it's going across. So the railing is going up and down for the modules to connect to it. And this is what the builder is going to have to follow for the configuration of it. We basically have the array pointing perfect south. That might change a little bit in the field depending on the slope of the area, but it's pretty flat from where we designated it. It is far though, that is for sure. As you can tell, like that is a very long conduit run to get up here to this equipment. So yeah. And then this is kind of what we're looking at from a side view on the ground mount. You can see we have the concrete pillars going into the ground. We did do some adjusting on this. Instead of doing 12 inches, we went with 16 inches in width on them. And we're still pretty deep at 4 feet, but they're 9 feet apart. And it got a nice little 20-degree pitch on the array. And yeah, definitely a cool little thing to do, and just keeping it simple, right? So yeah, this is your looking down at the array. This is looking at it from the side, and we are using iron ridge for all the connecting points. So we have mid clamps and clamps, and I believe we're using XR1000. Yeah, it says right here XR1000. That's pretty standard when you're using a ground mount. It's some beefy rail, and I'll show you the spec sheets. Now this is where things get interesting, is the electrical single line diagram. And we actually have several of them. So we have this one, and then we have the details for the calculations, and then we have the ADU one, and then the details for the calculations. Usually in a single line diagram, you don't have so much going on for most residential homes, but this is why you want to consult with someone that's, experienced in the field and can really understand what you're looking at. This is really good value for you as a homeowner if you're building a home or you're getting solar and you want to get someone to look at the plans before your installer submits them. I can do that type of consulting. Just schedule it on our website. You don't have to live in California for me to help you review something that you're not familiar with. And this is the point for you to catch any errors realistically. If equipment isn't being designated in the right location, isn't properly labeled, because having things not properly identified leads to corrections, which leads to delays. And when you have the federal tax credit expiring at the end of the year, the last thing you want is to have issues with your system. So this is the main house. It's getting the biggest of the site, of the design. So as you can see, we have 10.32 kilowatts of DC energy. That's 10,320 watts. And we have a 10,000 watt AC inverter. So we're pretty close to a 1-to-1 ratio. It's okay if your DC rating is greater than your AC output. That tends to be pretty standard, especially with microinverters. So kind of keep that in mind. We have our 400 amp all-in-one main electrical panel over here that's split in two. So we have two 200 amp main breakers feeding two different types of the home, the main house and then the ADU. So looking at this, we're going to go to the Franklin Whole Home A gate. This is the automatic transfer switch. This is what everything connects to, the generator, the solar, and the Franklin A.Power.2 batteries. And without this, you just couldn't do backup in this type of configuration. Even with the Tesla Powerwalls, which sadly don't support generators, they would require this if you were, trying to use a generator, because their backup switch isn't compatible with 400 amps. So you would always have to use a gateway of some form. Now, as we follow this downstream, so we got the meter connection going into a lug point on the A gate, and then we have our generator connection, which we can follow that. What's really cool about the Franklin system, and I think is really awesome for any of you that want a trifecta of backup capability. And what I mean by trifecta is you have solar backup, you have battery backup, and then you have generator backup. So that's really, really cool to have if you're in an area where you could potentially be going on months or days without power. This system, no matter what the weather condition is like, is going to continue to power the entire home. It has plenty of power to do that. And this generator with Franklin is able to power both systems. We didn't need to have two generators for each A gate. Their equipment does allow for you to use one generator for both systems, which is really cool. So as you can see, the generator is going to connect to a subpanel, and then that subpanel splits between the two systems. And you can see we're going back up to the main house A gate, and then we're also going to the ADU A gate. So this is basically duplicated. And the main house does have 3 batteries. So we have 3 15 kilowatt hour batteries, each capable of 48 amps max continuous power output. So we're looking at 180 amps of power surge capabilities. The surge is actually misspoken there. These things can surge pretty high, but 48 amps continuously at 240 volt. We're looking at 11.52 kilowatts of power each. So we're looking at 34.56 kilowatts of continuous energy, 35 kilowatts from the batteries. Trust me, you're not going to have any issues backing up this house. Now, we did have to use a CAN bus extender. Thankfully, Franklin was able to assist in providing details on which one they would recommend for that. I found a great value in that. And the CAN bus is the communication between the A gate and the batteries. Communication is very, very important with backup systems. So this is something that consulting with the right person is of value, because not all contractors, for one, would have probably been able to design the site for using one generator for both homes. And 2, they may have overlooked this CAN bus extender and possibly, caused conflict in the installation and the site working properly. So you got to keep that in mind. You want to be looking and working with people that think about the little things, which I think about every little thing, even down to the wire, which the engineer and I had to go over some details on that, and that led to some small changes. But we're dealing with some big wire because of voltage drop. We don't want voltage drop to be too significant because it can be a lot if we're dropping more than 1 or 2% over a 400-foot range. So we got it down to about 1.57, and hopefully that was based around 400 feet. I'm aiming for 350 feet is end up being the trenching distance. So that way we get closer to like 1.3, 1.2% in voltage drop, which is more than reasonable for the equipment. And then you can see we have 2 strings of 12 going to the Fronius Gen 24 inverter. And this was something that is important to note. The Gen 24 inverter only has 2 MPPT inputs, and they also do not support parallel connections. So the original design had 3 strings. That wasn't going to work. I had to get them to change that. And that's reasonable because most string inverters today either have 3 MPPT inputs and or 4. So why Fronius has decided to do 2, I don't know. But honestly, I don't think it's too bad because it works out pretty well for this ground mount system and keeps it really simple. Now we did do a fused disconnect, and I specifically went the fused disconnect down by the array and by the inverter because overcurrent protection is really important. And I want to make sure that the equipment stays safe. Given the distance of the run, a fused disconnect near the inverter made the most sense. We're always going to need some form of switchblade disconnect or lockable disconnect for first responders. Even though the inverter has a DC disconnect integrated, a fused disconnect is of great value because it's ensuring that there's protection if there's a surge or just anything on the AC side that malfunctions. It doesn't have to get all the way over to this circuit breaker inside the A gate. It could just blow a fuse and voila, the equipment's protected, the A gate's protected. I just wanted to create some extra protection there. As you can see, we have circuit breakers, a combiner panel, sub panel for all the batteries, and then that's connected to a 200 amp, which then connects over here. We will be using Polarises along the way because we have to downsize the wire on some of this stuff. So you can see number 3, this wire size going in the 2-inch, it's number 1, and then we're going to have to tape that down with Polarises to fit into a 60 amp. This is something where maybe my site supervision might be of value to you because I have seen contractors. It is very, very common for solar contractors specifically to just break wire off and then stick it in a breaker rather than buying the Polaris, because a Polaris is $50 to $100 each, and that's expensive. But a 60 amp breaker does not fit number 1s. I believe the max it can fit is a number 6. So that's where some of my services on my website are there for you, and making sure the job's done right, not just from reviewing plan sets with you or your proposals, but also coming out to the project and making sure that these guys install it properly, because they're not. A lot of the times they're just not doing good work. They need to turn and burn as fast as they can. Now here is the main house system calculations. We don't need to get on all of this, but we had to check on the array configuration for the strings. That's what I was looking at over here. For this, we don't want to exceed the 600 volt maximum input on this inverter, which we don't, based upon the temperature for the region. This also has all our wire and voltage drops and everything in there, what we should be looking at in terms of current. So this is all good information to review, and most of you may not understand it, and that's why it's good to just consult with someone that does and is familiar with these things. If you're looking to have a set of plans custom designed for your home, I can do that for you, and then you can just find the contractor to install the equipment for you. I honestly think that's a better direction to go. At the end of the day, you're probably going to get a better price, in my opinion, because you can just hire the electrician. I mean, this would be like a hybrid DIY configuration, in my opinion. And basically, you would consult with me to figure out the system you want. You have me design it with my engineering team, and then you take those plans, and I can either help you source the materials and equipment through distributors, or I can help you find contractors in your area, or you can find the contractors in your area. Whether it's a roofer to do the roofing aspect of the modules, or just an electrician to do the electrical work. Now, you definitely have a couple different avenues. Let alone, you could also find a solar contractor, and you might be able to get a little bit of a better deal with them. They're going to be pretty desperate for work with the federal tax credit expiring after this year. So kind of keep that in mind. You do have the upper hand here moving forward in the solar industry, and you have every right to demand a higher level of expertise. So here's the ADU configuration. As you can see, we are exceeding the AC rating a little bit more than the main house. And that's because we're trying to keep the system balanced. The ADU is smaller, but we still wanted to get a good system on there. So we have 6.88 kilowatts of DC energy, or 6,880 watts on a 6,000 watt AC inverter, or 6 kilowatt inverter. And the same configuration, 8 and 8, keeping the strings balanced. What's nice is there is room for expansion. You could always up this inverter to the 10.0 without any issues. The wire size is designed to be symmetrical. So this is the same number one as the 10 kilowatt inverter has. You would need to upgrade the fuses in here. But yeah, you can see in this one, we did the 80 amp PV breaker on it. And what we're trying to see is if the jurisdiction will let us do just a larger breaker in general, because I would rather put the maximum in the unit and go, hey, we have a fuse disconnect. It makes more sense, because if I can do the 80 amp, I don't think I need to use the Polarises. I'm pretty sure the 80 amp circuit breakers support up to number one. It might be number two, so it might be a lost cause at the end of the day, but but a 40 amp definitely ain't fitting no number one circuit breaker wire in it for sure. Number one, by the way, is about the size of most people's pinkies. So depending on the size of your hand, number one is going to be the size of your pinky, and then you get to 1/0, which is usually the size of your pointer finger, and then typically 3/0 is going to be the size of your thumb. And those are kind of rough estimates, but just to kind of give you an idea of how big the wire is, those are what we're looking at, and it really has to do with the distance. This wouldn't be the standard wire that we use. Now this site is a little bit smaller. We only have 2 batteries on it, but again, we designed it for expansion. So you can see we still have a 200 amp sub panel with a 200 amp breaker. There's going to be plenty of spaces available in here for expansion on this particular site. You can actually do up to, I believe, 15 batteries with the Franklin equipment if this homeowner wanted to do that. And that's kind of why I designed it going from the center out. So the batteries are on the outside. So that way the homeowner could expand more batteries on either side as they feel needed over time. And they don't have to do anything. The electrician would literally just connect another battery to the racking and then wire it up to the sub panel over here and then recommission the site to add that battery. They wouldn't need to do anything out of the ordinary. They don't have to pull any new wire. I designed this for future expansion, something many companies like to promote that they do and yet fail to do it in a successful way. We still have that generator split going on over here. As you can see, that Generac 26 kilowatt, A-gate, we got the 100 amp generator connection, rapid shutdown, the loads for backup, which is the whole ADU. We have the CAN bus extender again. So we basically have to have that for this site, because of the distance. And we want to make sure that this equipment has perfect communication, which it will with this CAN bus extender. So, here's our wire size and conduit schedule. And then here's the ADU system calculations that the engineer and I went over and ensured everything was good. And this was a pretty straightforward thing. Now here's the placard page. There's a lot going on this placard. As you can see, this is probably the most important one, I would say, is identifying where all the equipment is for first responders, so that way they know how to shut it off. What's really nice about the Franklin equipment is it supports rapid shutdowns. So there's just going to be 2 safety switches near the main electrical panel, and a first responder will be able to turn that knob, and bam, the batteries and the solar equipment's going to shut off, and it's going to be completely safe and self-contained. The DC energy is going to be contained at the array, so they don't have to worry about any DC energy coming from the array up to the house. which it wouldn't be because it's hitting the inverter right there. But they're also not going to have to worry about any AC energy coming over to the house either, even without having to run 400 feet down to pull those disconnects. So those disconnects though are down there along with these ones for the batteries. So if there was something near the equipment that needed first responders to shut off, they'll be able to quickly shut off all these devices one by one. Now here's some of the spec sheets. This is what the module is going to look like from Q-Cell. Great panel. Q-Cell makes some great stuff, and these are made in Dalton, Georgia, in the United States. And then here's the specs. We're going with the 430 watt module right here down the middle. What's really nice, I want to touch on the warranty real quick. So this is the degradation warranty of the Q-Cells. So you can see at least 98.5% of the nominal power during the first year. So they have that 1.5% buffer for year one. And then after that, the degradation rate should not exceed 0.33% per year. So they're basically guaranteeing at least 90.5.8% of the original nominal power output at year 25, which is really high. The highest in the industry is from REC Group, and that one is, I believe, 92%. So yeah, this is a substantially good warranty, and it's made in America from a trusted manufacturer. And then if we look at designed, right, this is the Fronius Primo Gen 24 inverter. This is what it's going to look like. Nice, compact. It has a fan on it. And yeah, it's a great design. I've done a video with Fronius. Be sure to check it out. I've checked out this equipment a couple different times. They have some unique features to it that made me want to go with it over some other equipment, because I definitely had some other choices, but I really leaned into using this one to create a hybrid commercial site. So if this homeowner wanted to add batteries on the DC side, they technically could do that with this setup. And these are just the spec sheets. As you can see, everything looks good here. And I believe the warranty details on the Gen 24, I want to say, I know it comes with a 10-year warranty standard, but I think once we register it, I think it gets an extra 2 years for free. So I'm pretty sure it'll end up with the 12-year warranty. And yeah, that's a good warranty for a string inverter. These units, I've seen a ton of them out in the field, not these newer ones, but just Fronius equipment in general. And let me tell you, these things just keep going. They are so good. A string inverter has really, honestly, one of the lower failure rates in the industry. Don't be fooled by microinverters all the time. It can be a little misleading on how it's advertised on their failure rates, but a string inverter technically does have a lower failure rate. You can see this unit is being manufactured in Austria. I think that's really cool that they show you the country of manufacture. So, but great equipment. If you wanted SMA America, happy to work with you on that. If you wanted a Tesla solar inverter, we can do that. There's other brands out there, but I'm going to advise on what I would recommend for your site for long-term reliability and serviceability. Now, of course, we went Generac on the inverter. There's other units available. This is just an air-cooled gas generator, liquid propane, natural gas, comes with a 5-year limited warranty. And we went with the bigger unit, 26 kilowatts, because we're splitting the power between both sites. So we wanted to make sure there was ample power to power the homes and keep the batteries charged. So everything you need to see right here. The Generac is a pretty good inverter, or it is a pretty good generator in my opinion. You got to do your regular maintenance on it, but it does have, typically they have standard Wi-Fi connectivity, and you'll be able to do various things to just check on the system and make sure it's going to do maintenance. It'll do its monthly cycling start, so it turns on, shuts off, and it's pretty straightforward for having a generator on site. These are the details. It's important to note that power variances change. So natural gas, it drops the power rating. So they're going to be using liquid propane. So they're going to get pretty close to the maximum power output, which is 26,000 watts or 26 kilowatts. And then, if they were using natural gas, which this site isn't, it does, drop off about 10% or so of the power. So not have to worry there, but just something to keep in mind for yourself. It is using a 1,000 cc generator, which is pretty crazy, 999 cc's. It has 2 cylinders. So it's like a little 2-stroke motor. Well, it's not really a 2-stroke, but it's a little engine, and it'll keep running as it needs to. Here's what's really nice is they do break down how long you can expect it to run, depending on the load. So you can see 75 hours at half load. 100, or that's how much it's consuming, how many gallons per hour. 132 gallons per hour. So that's 3.63 hours. So yeah, if you were really cranking on it, you can consume a pretty big sized thing of propane, no problem. Then we have the switch that goes. Oh, we're not going to be using this switch. We don't need it. So it's in there, but we're not going to be using it. And this is kind of the dimensions of everything. We did include the gen pad, so that way, hey, yep, we got to put it on a concrete pad. And the gen pad is a great pre-designed one. They also have a hurricane one, which is just a little bit thicker. So if you live in an area where hurricanes are an issue, they do make that version available to you as well. But yeah, there you go. There's the gen pad that we'll be using, be able to bolt it down. Here's what the A.2 looks like. Nice, gorgeous looking battery, 15-year warranty, 10 kilowatts of continuous power, 15 kilowatts of peak. So plenty of energy. And remember, this person has 3 units. So 15 kilowatt hours of storage. You're not getting anywhere. And it was that you're not going to have to worry about anything on this. And it was 15 units per A gate. So yeah, they could, in theory, have up to 30 batteries connected between their 2 homes if they really wanted to go all out. I don't think anybody really needs that many, but your situation might differ. So everybody's situation is different. That's why it's important to consult with someone like myself to help you figure that out. Here's what the A gate looks like. Similar to the battery, it is hassle-free, and it's a great product. Comes with a 12-year limited warranty. And then this is the racking. So you can see the Iron Ridge XR1000, very solid design, great for using on commercial projects and or ground mounts. You can see they have different models. This is one you typically use in residential. This one can be used in residential, and it just allows for a larger span. And then this is the most common one used in solar mount, for ground mounts. And it's just because of the spans. And then you can see the rail spans to wind or snow load. This is solid equipment at the end of the day. Here's what some of the parts are going to look like. We have L feet, tilt legs, end clamps, mid clamps, grounding lugs. There's small accessories. It's important to note that this type of racking only comes in mill typically when you're dealing with ground mounts. So it's not often anodized like the residential stuff for roofs. And then these are the UFOs. Great product, and they hold up. There are definitely some better products out there, but this is honestly still a great design at the end of the day. The bond splicers, we're going to need that, so that way it's continuous grounding all the way through. You got your bonding attachments. This is just kind of a general diagram to kind of see, like, okay, you ground this rail, ground that rail. You basically ground every other rail, right? And then it becomes continuous grounding for the entire thing. This is what it looks like without any modules on it, if you were curious. So that's more or less, we're going to have 2-inch posts coming out of concrete, have a post attachment to 2-inch piping going across, and then, the rail's just going up and down. That's it. Pretty straightforward, right? And no compromise there at all. This is what it kind of looks like from the underside. Remember, if you subscribe to the channel, you'll be able to see the construction of this product in this site. And it's going to be an awesome one. We have a couple lined up, so be sure to check it out. And if you need assistance, reach out. I'm here for you. And then this is the range extender. There you go. That's what it does. The CAN bus range extender. And I don't think I need 2 of them. I'm pretty sure I can just use 1 to extend the CAN bus for the site, but we'll have to see. I might have to have 2. I don't want to have interference, but it has the necessary inputs for up to 4, it looks like. So we should be able to just plug in A gate 1, plug in A gate 2, and use 1 unit to extend the range as needed for the site, because it is some significant distance. The rest of this is just all that general information on how to configure it and set it all up, which I'll be out there consulting and handling this with the contractors and whatnot. So yeah, that's the site I kind of am really excited to be working on and really excited to show you. Be sure to like, follow, and subscribe because this is going to be one worth observing. And if you are someone looking to have something custom done, or you have a project in place and you want to make sure the equipment's being installed properly or whatever it might be, visit my website, reinnovations.org, and look at some of the services on there that we have available. Pricing's public. It is subject to change. You know, those aren't fixed costs. It depends on the complexity of your project. But, I'm here to help you as the homeowner make sure you get the best setup you can and you have as little bit of issues as possible. Because at the end of the day, that's what the industry needs, is someone like me and others out there, because there are other great consultants in the industry. Joe from Solar Surge, Martina from Solar Time, Solar Boy, I can't think of his name, but those guys they're all great people. So if you're familiar with their channels, be sure to check them out too. Joe has a lot of technical information on various products. He seems to be jumping around all over, getting footage with different manufacturers. But I'm here for you and making sure your home gets transitions to clean renewable energy in a costly way and in a way that's done professionally. So thanks for checking this out, and I hope to show you off the installation over the next coming months.